Hey, welcome everybody to 12.3 Part 2. So this example that we were just finishing up in the last video, there's actually 26 red cards, so this should be 26 right here. But I just realized that I think I believe that there's more than one way to do this problem, and I would like to go back and triple check to make sure that either way will work before I show you both. So we're going to pause on that example and I'll come back another time to do that. Alright, so let's move on to example 3. So looking at this dartboard, each one of these rings has a each of the rings has a distance of 3 units here, and the radius of the center circle is also 3. I know that my picture is not drawn to scale, so the bigger the center circle should be a little bigger there. It's not, sorry. So, but it does have a radius of 3. So here are the point values: 0 if you get outside, 2, 5, and 10. The question is your dart, if your dart is equally likely to land anywhere on the board, are you more likely to get 10 points or 0 points? Essentially, we need to figure out the probability of both of those happening. So I want to find the probability of getting a 10 score, and I want to find a probability of getting a 0 score. So if I was going to get a score of 10, I need to hit the bullseye. And when I'm talking about something like a dartboard, our probabilities or our number of outcomes will actually be the area of the surface. So what I want to do is I want to figure out what's the total area of this dartboard and what's the area of the bullseye. Then I'll be able to figure out the probability. Notice that the bullseye is a circle. Area formula for a circle is pi r squared. So that is the area of the center bullseye circle. Notice that the entire dartboard is a square, and we don't actually know yet what the sides are. So let's just think about this really quick. If I look at half of the dartboard, each one of these rings is 3 units, and there's 3 of them. So half the board is 9. So the full distance across for one side is 18 then. And again, I got that by adding together the ring amounts. So it's a square, so I can do 18 times 18 for my area. Now, be careful when you type this in. I want 9 pi together divided by 324. And we end up with 0.0873. So that's our probability of getting the bullseye. Not a very good chance. And now we want to figure out the probability of getting a 0, and the 0 would be this area here. I still want the total area for my bottom amount, and we figured that out before, so I'll just keep it as 324. It's still the same circle, or same square. I want outside the circle area for a score of 0. And here's where it gets a little tricky. Think of it like a donut hole that I have to subtract off. So what I'm going to do here is I'm going to take the square area and I'm going to subtract off this big circle. If I take the big square area and subtract off the circle, what I'm left with is the outside edges. So in words, I'm going to take the area of the square and I'm going to subtract off the full circle, so the outside circle. I know already the area of the square is 324 because that's what we just did. The outside circle, we got to figure out the radius. So I'm thinking 3, 6, 9. So 9 is the radius. Pi r squared looks like this then. Now, be careful, because if you're going to do this in your calculator, you want to type it all in parentheses always. Otherwise your calculator won't know to separate them. Type it all in and you get 0.21. So let's go back to the question. Are you more likely to get 10 points or 0 points? And obviously the 0 points is a higher number than the 10 points. So you are more likely to get 0 points. That is kind of a hard problem. So again, please write down questions you might have and we can talk about them when we get back to class. We've got one more thing to do today, and it is experimental probability. Experimental probability is probability based on survey results or experiment results. So it's based on survey or experiment results. And some students feel like this doesn't even seem like you're doing probability, because what you'll usually do is you'll just be finding percentages based off of given information. It is technically still considered experimental probability though. So let me show you what I mean. Look at this table. I got a 1998 survey asking internet users for their ages, and the results are shown below. It'd be really interesting if I could get some more current data, but there we are. Part A, what is the experimental probability that a randomly selected user is at most 20 years old? So if I want to figure this out, I want to know how many people total took the survey, and then I want to figure out how many are under 21, because at most would be 20 or younger. So how many are under 21 divided by how many people total? How many under 21 I could just take straight from the chart. That's 1636. For how many people total? I'll save you some trouble. I added all of these together earlier and I got 12,443. So divide that off and you get 0.13 or 13%. Now that I've done a problem, you might agree with me, it doesn't really seem like we're doing probability, does it? It more seems like we're just finding a percentage, like 13% of people were under 21, instead of probability would be 0.13. So don't let the word experimental probability throw you off, is what I'm trying to say here. It is simpler than it sounds. Look at part B. What is the experimental probability that a randomly selected user is at least 41 years old? Okay, we still got the 12,443 people in the chart, but now I want the 41 years old or older, so I'm going to add together all of those. So 3693 plus 491 plus 6. And I end up with 4,190 divided by 12,443. So the probability of seeing someone of that age using the internet in this chart was 0.34. That's all I got for you today. Thanks for listening. Have a great night.